In the final two clips, we will start studying redox reactions. Reactions where one atom becomes more oxidized, it loses electrons, and another atom becomes more reduced. It gains electrons. And we are going to study this redox reactions in aqueous media. And in aqueous media, which is to say water, we have the complication that in basic water, we have, of course, H2O, but we also have OH minus. And in acidic water, we have H2O and H plus. So we have potentially reactants in the reaction that we don't know about coming from the water itself. And the example that we're going to look at today is a reaction in base. And the reaction is chromium I3 aqueous plus hydrogen peroxide aqueous goes to make chromium O4 2-, the chromate ion aqueous, plus iodine O4- aqueous. And remember that we don't yet know if water, and since this is base, or OH- are involved. And we're going to use the half reaction method to balance the reaction. The first step is long. These are 4 steps that are very important, and they need to be followed exactly to find the half reactions. I'll read it what it says in black. Find an atom whose location in a product and reactant compound is self-evident and whose oxidation state undergoes a change during the reaction. And so we can see my eyes are immediately drawn to the chromium. The iodine here is the more electronegative atom. It's -1. That makes the chromium 3. The oxygen is -2. It's the more electronegative atom. There are 4 of them, -8. For the 4 of them, 2 of the electrons come from the 2- charge of the chromate ion, and the remaining 6 come from the chromium. Chromium, its location is self-evident on the 2 sides, and undergoes change of oxidation state. The second sentence of step 1 is place the compounds and ions containing this atom which undergoes the change and place them into your first half reaction. So the first half reaction consists of CrI3. I'll drop the aqueous, going to CrO4 2-. And now you must follow the next 3 steps very carefully. And so let's read what it says. Balance your first half reaction for all elements other than O and H. We don't know if water is involved or OH- is involved. We therefore don't even know the charges. We cannot balance from them because we don't yet know if there are other additional players in the reaction. Okay. But there is one, we are balanced for chromium right now. There's 1 chromium on both sides, but we are not balanced for iodine. To balance for iodine, we're going to have to add, I'll add it right here, 3 iO4-. And now we have balanced for all elements other than O and H, and we're not worried about charge. That's the first half reaction. We can now move to the second half reaction. And it states, choose all compounds and ions not contained in your first half reaction as your start for your second half reaction. Well, we've already done this one. We've carried out this one. We place this one. There's only one that we haven't used. It is H2O2. And now we're at the fourth step. Balance your second half reaction for all elements other than O and H. Do not balance for charge. Well, there's only O and H in this reaction. So this has carried out the second step. It's balanced for all other elements in O and H, for which there are none. We aren't worried about charge. This is the starting point of the second half reaction. And it turns out that the hard part of the half reaction method of rebalancing reactions is finding these two starter reactions. So having found this as the first half reaction and this as the second half reaction, it's all going to be easy peasy to complete the balanced reaction.